All right, everyone. We're going to get started here shortly. Just so you know, we are recording today's webinar, as we will be for the entire series of our February webinar series. So with that in mind, let's go ahead and get started. I want to welcome everyone to the second of our series. Today, we're going to be focusing not on nitrogen like we did last week, but on potassium. Potassium is generally known in the industry as sort of the quality nutrient, and in specialty crops, that's a really clear correlation. In row crops, it's increasingly important as well. In recent years, we've started to see a lot of foliar potassium being used in mid to late season applications in row crops, and it's all about getting that optimal quality yield in your harvest so that you get the most bang for your buck in your payout. So let's go ahead and dive in. I did want to just preface this by saying that our Chief Technology Officer, Mark Slavens, is not feeling too well today. So today you just got me. So let's go ahead and dive in. If I can figure out how to advance the slide. Sorry, guys. There we go. Okay. So potassium fertilizer use is growing across all of global agriculture over the last few years. Some of that is attributed to increased climate change effects. Potassium has a really, really strong role to play in osmotic adjustment for plants, drought and heat stress responses, along with a lot of just developmental procedures in plants as well. We're going to be talking about that here in a bit. So as the acreage of specialty crop and demand for specialty crops and ethanol related grain production has gone up, so too is the demand for potassium to keep those harvests and harvest qualities up as much as possible. You can see here that countries do sort of variable efficiency at using and leveraging potassium in their crop production, and a lot of that has to do with what crops each region of the world is sort of best suited at growing. That's going to have a pretty large impact on just how much potassium needs to be added to the available soil pool every season. Okay, so fertilizer use in general is going to be impacted by the crop grown, like I've talked about, but also the length of the growing season in general, soil pH, soil texture, salinity, and other critical agronomic factors. Specifically, how much water can you apply to your crop? Is it a deficit irrigation situation, or are things under ideal hydration conditions? So in terms of how much potassium do plants need, turns out that varies quite a bit by crop. In general, you want to make sure that you're applying your potassium fertility over the course of the production season. You want to make sure that maintenance, that threshold level of potassium is available, not just in the soil, but available for crops to take up. And so wherever that critical level is for your crop and your soil, and typically extension services and agents can provide those thresholds, you want to be able to maintain those levels and then essentially provide a little bit extra for a buildup of available potassium in the soil pool. So generally, there's going to be a deficient range of that available potassium, an optimal and a sufficient range to make sure that crop yields and quality are at their best. So potassium is like I said, really intimately involved in quite a few, stress responsive procedures in crops, but also just developmental cues as well. So it's really a foundational element to a sound fertility program in crop production, from Maine to San Diego to Seattle to Key West. You can see here one of the old aspects of agronomy classrooms and horticulture classrooms was this Mulder's chart relationship that shows how nutrients sort of respond and interact with one another in terms of their role in plant physiology and development, but also an uptake from the soil. And you can see here, dotted lines are meant to indicate positive relationships. So that, for example, phosphate has a positive role in magnesium uptake, but magnesium, or calcium can compete for magnesium uptake. So that's indicated by the solid line here. Ever since the advent of the DNA and sort of high throughput chemistry era in plant research, some of the role and importance of things like this has gone away. But I think it's important to revisit some of these concepts because there's a lot of information here that DNA and genetics and chemical analysis are only now starting to resolve the mechanisms of. So it turns out that potassium is consumed pretty much universally, although in variable amounts, across plant species. What does it do? Well, it's really important in maintenance of cells' osmotic potential or turgor pressure, basically how swollen of a water balloon or a plant cell, how swollen of a cell can that plant maintain. That's going to be dictated very strongly by the content of potassium in the cell. If people are familiar with what a guard cell is and what stomates are on leaves, it turns out that potassium movement into guard cells is what actually opens up those leaf stomates and allows gas exchange for photosynthesis to occur. So whenever potassium is deficient, you can expect photosynthetic activity and basically canopy health in general to go down pretty quickly. And I'll show you some pictures in a bit. Potassium has a really important role as activating some of the enzymes directly involved in photosynthesis across all plants. So obviously important there. It's very important in driving some of the enzymes involved in respiration, in the mitochondria specifically. Because of its role in helping plants to maintain water status, there's obviously a really important role to play in drought tolerance, heat tolerance, in your plant tissue. And it also has a role to play for winter hardiness, where osmotic adjustment in your plant tissue has a really large role to play as well, right? Keeping that electrolyte content high when and where needed can stave off tissue freezing and then also, subsequent damage from it. Potassium has a really large role to play as well in disease resistance, specifically penetrating insects. Just don't like physically thicker, more bitter, astringent tissues, and that's where potassium has a role to play as well. So insect tolerance and subsequent diseases conferred by those insect predation events can really be inhibited by adequate potassium nutrition in your crop. So a little bit of redundancy here, but just to present a model of a corn plant, we see that potassium really has roles from the crown, the growing tip of the plant, all the way down to the root system as well. In summer stress, turf grasses are often supplemented with additional potassium to increase cell thickness, cell wall thickness, summer osmotic stress resistance, and then finally to promote root growth in combination with phosphorus as well. So potassium is going to be absorbed in the K plus monovalent cationic form. And in that form, it's highly, highly mobile. So it can be taken up quickly, but it can also be lost in the soil matrix rather quickly as well. So in terms of agronomic roles, in specialty crops, potassium has a really large role to play in tree fruit production, tree nut bloom. Basically, if you want to make sure that you're harvesting a really solid tree fruit crop or tree nut crop off of your orchard, you want to make sure that your trees are setting an adequate bloom. And if that's not happening properly, then you're not going to get enough pollination events and then subsequent fruit development on the tree. So one of the main things that tree fruit growers and tree nut growers ought to be thinking about at about this time of year, depending on where you are, obviously, is getting some supplemental potassium into the root system of these plants. And, okay, looks like we have a late comer to the party. That's good. Okay. So yeah, really, really important to get that available potassium supplemented into the soil now, so that when tree anthesis and bloom out comes, and down in the Fresno area, almond and pistachio trees, that bloom out period is going to be coming here pretty quick. So now is the time for potassium nutrition. Speaking of tree fruits, potassium levels are really highly correlated to root development. So it's not just a phosphorus game when it comes to root growth in tree fruits. You really have to make sure that there's adequate potassium as well. And specifically, not just pushing potassium levels ever higher and higher. It turns out that many tree fruits, specifically in Rosaceae family, such as apple, which is what's pictured here in a study depicted in 2020 from Frontiers of Plant Science, that apple root stalks specifically grow best and develop more root mass when applied with 6 millimolar of a potassium solution. And any lower than that, you get less root development. And interestingly, any higher than that, as shown here, you get significantly less root development as well. This is double that concentration at 12 millimolar. This data was collected in 2018 and then repeated in 2019, and you can see the exact same response profile there as well. So interestingly, again, if we look at different replications, different root stocks, that same pattern comes into play. So clearly, there's sort of an ideal role for not just potassium nutrition, but maintaining a really narrow range of that ideal potassium level available to the plant to elicit the best growth response possible. So continuing on with that message, we see that different levels of potassium not only can accelerate root growth, but there's a specific response that canopy development is targeted for even higher accelerated growth. And again, at that 6 millimolar application level. So too much, and you don't get as much leaf development, as much root development, or shoot development. And that's measured and that's reflected also in the combined total biomass over here, measured by radio-labeled nitrogen accumulation. So clearly, that ideal level of potassium application can trigger desirable growth in the root, shoot, and the canopy that you want. That's similarly reflected here, but another interesting aspect of potassium is that it prefers or sort of acts antagonistically with ammonium uptake, but appears to promote nitrate uptake. So keeping ideal potassium applications at that 6 millimolar level can dramatically help the plant, in this case apple, to take up nitrate, but it might not help you take up ammonium. So that can help you make a better informed decision on the type of nitrogen that you want to deliver in a potential mix with NanoK or potassium as well. Potassium uptake, magnesium, and definitely sodium uptake from the soil can be impacted positively in the case of calcium and magnesium, and negatively in the case of sodium, based on that ideal potassium application rate. And again, this is reflected in a 2020 paper in Frontiers of Plant Science. Because of its mobility in plant tissue, not only in the soil, but once it does get taken up by the plant, you're going to see deficiencies show up really quickly. And where it does tend to show up first is on old growth of plants. So this is going to be, basal leaf tissue. Thank you. Okay. You can see here, this is going to be basal leaf tissue in field corn. You can see that yellowing popping up here. Looks slightly different than general nitrogen chlorosis in that you see it on the leaf margins of old growth specifically. If this was nitrogen chlorosis, you'd see it on younger tissue first, and general yellowing would appear not just in the margins. You can see here over on, I believe, spud canopies, a similar potassium deficiency. And potatoes are notorious for being able to take up adequate levels of calcium, phosphorus, and specifically potassium later on in the growing season. So foliar applications of potassium are really, really common. And if you're not able to hit adequate levels in the tissue, this is typically what you see. And, potassium levels, free potassium levels in the soil are typically pretty accessible to the plant, where you do tend to start seeing problems with deficiency. Number one, in high salinity soils, but number two, in highest acidity soils. The import mechanisms for potassium tend to slow down to a complete halt under pHs of about 5.5. If you go even lower, it tends to get even worse. So managing potassium in acidic soils typically leads to the need to sort of supplement that available potassium pool quite a bit more frequently, or the alternative is to just get your soil pH to a level that makes potassium uptake a lot more efficient. So with that framework in mind, enter NanoK. NanoK is our potassium supplement product. It's not necessarily intended for foliar application. It does a really good job through application of the root system or in foliar application. I'll talk about why that is here in a second. Turns out the potassium uptake through foliar methods can really, really vary in its efficiency by the form of that potassium. If it comes in potassium acetate, you can expect about 45 to 50% of what you're spraying and staying in contact with a soy leaf tissue to actually make it inside that tissue. But notice the precipitous decline in the amount of that potassium that actually makes it into the tissue as you start to move away from the potassium acetate form that makes up our NanoK. When you start looking at potassium phosphate, that uptake goes down to 35%. At potassium citrate, which is granted an easy product to work with, not quite as easy as potassium acetate, that uptake goes way down to 12.5. And you can see some of the other higher salt index forms of potassium really just not doing a great job of being readily available for uptake to the plant. Now, what are the reasons behind that? Well, as I mentioned, there are variable salt indexes associated with each of those potassium sources. And what does the salt do? Well, basically, there's a game in the root zone of soils pulling and trying to hold on to water, and plant root systems trying to do the same thing and pull that water away from the soil colloids. Salt tends to increase the pull of soil on any bound water in it. And if that pull becomes too hard or too great, then plants really can have a hard time accessing any water or any dissolved nutrients in that water needed for health. So potassium acetate, as you can see here, has one of, if not the lowest salt indexes associated with potassium sources that are common in the market right now. And you can see things like potassium chloride, simple, essentially road salt, having some of the highest salt indexes out there. And then finally, the point of deliquescence, that's what's abbreviated by POD. Turns out that potassium acetate will start to take on water at such low relative humidities that it really is just a really stable product once it gets in solution. So all the way down in dry air of 23.3% relative humidity, you'll start to see potassium acetate powders start taking on water quite readily. And you can see that's not the case at all for some of the higher salt index forms. Okay, so in general, NanoK is a really fantastic product that's going to help drive potassium into the tissue based on existing nanoliquid technology more readily. And because of that, you're going to get higher crop quality. It's going to strengthen plant cells. And because of that, you're going to specifically plant cell walls. And because of that, you're going to get improved heat and drought stress responses and stress tolerance. It's going to mitigate drought stress with water regulation and allow you to apply less salt per acre per year. It is highly, highly compatible. That acetate group bound to the potassium ion in NanoK is really compatible with other, chemical forms. So it's a highly, convenient and compatible product to work with in complex tank mixes. Finally, it's clean, easy handling, safe for the environment. Also, that that gets down to the low salt index. And increasingly, this is something that's becoming something on the radar for a lot of growers throughout the country. Water quality maintenance is of increasing concern to local jurisdictions, and we really feel this is a tool to help growers stay in compliance while maximizing their crop production sustainability. Just to sort of speak to that convenience a little bit more, we recommend a 2 to 6 ounce application rate with NanoK, and you can basically start developing a tank mix by starting with a little bit of water. Any AMS or water conditioning would then get applied before adding in your fertilizer, your raw potassium fertilizer, and then finally adding in the Nano-Yield nanoliquid, in this case NanoK, to help bind and stabilize that other fertilizers and help get that material across your production space and into the plants as best as possible. Okay, so just some quick review for anyone not familiar with the existing product line. For 2022, we have 3 OMRI certified products, 1 OMRI certified crop protection product, 2 crop nutrition products. That's OmniGrow, OmniPro, and then our biological CX Pro. We also produce quite a few crop nutrition products, ranging from basic NanoK to a sort of complete NanoGrow at a 710-1. We also produce a NanoCalci and a NanoStress at a 0.1721. All of these products, NanoK included, leverage our nanoliquid technology, and you can really think of this as an advanced delivery system for your agronomic input of choice, whether that's fertilizer chemistry or more expensive, bulkier crop protection chemistries. And how does that work? Well, basically, we take our nanoparticles at about 1 to 100 nanometers in outer diameter. And because of that really small diameter, we're able to have a really large surface area in solution. And it turns out that each one of those particles is able to attract and then bind, interact with, and stabilize anywhere from 1 to 10,000 of these target ions. So in the case of NanoK, that means we can start loading potassium ions onto the surface and also on the inside of our nanoliquid technology. And what happens is these loaded particles then interact with either the leaf surface or the root system and are taken up by the plant, where their cargo is then released. The technology itself, this is a great look at what it actually looks like under a fancy microscope. This is an electron microscope image from a local university. And you can see here 2 important factors to the particles themselves. You can see the surface sort of has a non-uniform, technical term is tortuous, curvy surface to it. Basically, you can think of this as sort of the nooks and crannies on a Thomas's English muffin. All of those nooks and crannies allow for really robust loading of nutrient ions for delivery to the plant tissue. You can also see here on the right a little bit of light passing through the center of that particle in a slightly near-field focused image. And that basically shows you that there is indeed porosity associated with these particles, and there's an interior void space in which we can load our active ingredients. So if you are delivering crop nutrition or crop protection chemistries through any liquid means, our products work with your system. How do the particles, once loaded, actually get into the tissue? There are 3 pathways, 2 of which are foliar. We can have loaded particles land onto the cuticular surface of leaves, the adaxial or top side A lot of people think that surface of leaves, the cuticle, is sort of a smooth saran wrap layer of wax. Actually turns out it's quite a bit, cracked and fissured, and loaded particles can find their way into those cracks and then start moving into the interior of the leaf where their cargo is then unloaded. Loaded particles can also find their way into the stomates on the underside of leaves, where again, their cargo is unloaded, and then we see translaminar movement throughout the plant. And sure enough, the third and final uptake pathway is through the root system. We've shown that loaded particles are able to make it inside the root system through interaction with root hairs and subsequent endocytosis, a process in cells that allows them to sort of scoop up bulk materials in their outside and sort of process what the package contains. So with that in mind, I wanted to sort of get into a few field performance highlights of NanoK from recent years. NanoK is easily one of my favorite products that we offer. It's a really simple, stable product. Its formulation offers some of the most mobile, most accessible forms of potassium in the industry. And that really has a lot of important impacts for growers, regardless of what their production type is. We've worked in the past with some greenhouse growers in Central Texas. These are guys that are producing starter melon plants for some of the regional field melon production industry. And some of these growers, we've been able to help reduce both their potassium and phosphorus inputs by 33 and 90%, respectively. We have worked with one grower who was historically used to producing 3 melon starter crops per year. We've helped him not only reduce his input costs, but accelerate growth from 3 crops to 4 in a production year. So pretty cool stuff. So following that story into some of the surrounding field production industry, we've worked with some growers in the Hayden, Arizona area over a few years now, and we've helped increase their yield in both number of melons taken off of an acre, but also the quality. And when it comes to specialty crop production, really a lot of what your payday boils down to is in the quality and size of the actual fruit that's reaching a pack house and eventual market. With this grower, we were able to raise Brix or free sugar levels in the fruit from about 8.5 in the untreated to 12 or more after 3 NanoK applications. These fruit not only were sweeter, but they were 15% larger. They had darker meat, which means they were higher in nutritional content. And that very first harvest, again, was 45% larger by quantity. So pretty cool stuff there. Yeah, he also grew cantaloupe, and that raised from 12, which in itself is a pretty sweet melon, all the way up to 16 to 18, which is like candy. There's been quite a bit of work with NanoK done in both lowland cotton and Pima cotton, interestingly. In 2018, a study was conducted with Texas A&M using one maintenance application to prepare a production field for a cotton crop to hit a soil level of 160 ppm. In that, a single NanoK application was performed, and sure enough, in response to that, we can see these green treatment bars here, definitely being significantly higher in potassium, as you would expect, than the untreated. But interestingly, and we also know this because of the Mulder's chart and knowledge that potassium has a good interaction with calcium uptake, sure enough, we see significantly higher calcium levels as well. We've done some corn We've done some studies with corn in the Northern Plains. This is from a 2019 study done with Stenzel in Minnesota. And what we wanted to do here was compare our potassium source to a really common competitor. And sure enough, when combined with a micro package, the Brant Quattro, and no potassium alone, we were able to get yields of about 185 bushels to the acre. The check here shows 181, but sure enough, when we have the micro package and NanoK, we can boost that yield all the way up to 187.5 with a competing K source and the Brant micro source. We have a yield at about 184 to 183 again. So a really nice visual boost there that you can see from the addition of a potassium acetate product relative to a competing source. Okay, that data also borne out with kernels to the acre as well. So not only were we getting more of a yield, but each cob was loaded with more kernels as well. Corn is a game of acreage and economies of scale. When it comes to specialty crops, really quality is the name of the game. We've been able to work with a researcher at Washington State University in the Yakima campus in 2019. And in that study, we evaluated yield of hops, a pretty high value crop in that area, after 12 applications of NanoK at either 100% rate or a reduced foliar fertilization rate. You can see here on the bottom are pounds that we're actually getting out of the harvest of hops. If we take that regular rate and add NanoK to it, we actually get less than what we were able to elicit if we reduce that full application rate and consequent salt load associated with that full rate and add NanoK to it. So pretty impressive results there. We've been able to look at the response of sugar beets, another really common commodity crop up in the Northern Plains. This was a study done in Wisconsin in 2020. We worked with a grower who typically, produces huge acreage of the crop. A Czech population of sugar beets was at 13,000 acres. This was untreated with NanoK. And this was compared with the yield against a small 150-acre test plot that received NanoK as an in-furrow starter. And you can see just a really nice boost in pounds of sugar per acre recovered from that test plot, as opposed to the remaining 13,000 acres of the untreated. When it comes to crops like this, sugar cane, sugar beet, sugar or orange juice, orange growers down in the Southeast, really that pounds of sugar per acre that are reaching the pack house, that's what determines or has a really large role to play in eventual payoff. So this is really exciting data. In 2018, we were able to conduct two parallel studies in the Pacific Northwest, sort of the mecca of American potato production. One study in Idaho, sort of incorporating a full AquaYield product program and fertility program. And then an additional study in Washington, just looking at AquaYield product use as an in-furrow starter. So for the Idaho study, you can see it was a really robust program here, but NanoK was applied for the first half of the production cycle, and then another potassium source, but a little bit different, that I'm sure we'll talk about later. NanoStress was included in the later half of the production cycle. So let's take a look at what that was able to accomplish. The regular fertility program without AquaYield products is represented here. The addition of the AquaYield products, as I described in the previous slide, cost total, this is all products combined, about $55 to the acre. But sure enough, looking at the improved yield, not only in total yield, but by grade per acre, there's actually a nice return on investment there of about $130 to the acre. So pretty encouraging stuff there. In Washington, again, we just used a NanoFos and Rise in furrow, so I guess not too applicable for a NanoK discussion. So in general, direct benefits of NanoK integration into your fertility program are as follows. Because of the potassium acetate source associated with NanoK, you're just going to get a much more available, readily accessible form of potassium in the free potassium pool in your soil. If you're applying it foliarly, there's plenty of evidence to suggest that potassium acetate, and then that acetate boosted by the nanoliquid technology, is just one of the best, if not the best ways of delivering a quick spike of potassium to your tissue on the market. It's more efficiently absorbed, and because of that, it opens up the possibility of reducing applied potassium rates to your production space on a per acre per year basis. Because of that, you can start accounting for reduced annual salt loads applied to that production space on an annual basis as well. So we really feel this has a role to play in agricultural sustainability, and maybe even efforts related to restorative agriculture as well. You can definitely see a rapid tissue response in the presence of any environmental stress, whether that's drought or heat stress. Any application, specifically foliar application of NanoK, is going to give you a visual response that really shows you that the plant is more resilient to that stress. NanoK and potassium uptake in general has a really great impact, synergistic impact on uptake of additional nutrients. Calcium and magnesium are probably two of the most important ones. Sulfur would be another example. In general, there's a stoichiometric positive relationship of available potassium uptake by your plants to nitrate uptake in your plants. And really, this is also informative to help growers determine what the best source of their nitrogen fertility in combination with potassium should be. And because of that, it's highly, highly compatible in complex tank mixes, really easy to work with for that reason. Every product has, is a work in progress, right? I like to say, we adopt the Lexus mindset of the constant pursuit of perfection. So what are the future directions for NanoK? We definitely want to further demonstrate enhanced nanoliquid potassium acetate mobility in diverse crops. We're always on the lookout for how NanoK responds in sort of unusual production systems, unusual soils. We definitely want to characterize how much of a reduction in applied potassium can be achieved by using NanoK in combination with grower standard traditional K fertility programs. Really getting an idea of what kind of numbers we're working with can help us characterize what the ecological impacts of integration of NanoK can be. We want to expand the impacts on specialty crop and row crop harvest quantity and quality. Because of just how mobile and accessible potassium acetate boosted by nanoliquid technology can be to crops, we really want to collect a robust idea of return on investment by using NanoK across tons of different specialty crops, high value crops, where cost per acre is a little bit higher than row crops, but also get that row crop data as well. We want to be able to quantify, in general, a NanoK dose-dependent impact on stability in complex tank mixes. A lot of people like to use potassium in combination with, spoon feeding nitrogen. So we just want to see how that interaction might play out as well. All right, guys, so that is our presentation for today. Again, apologies for the absence of Mark today. He's feeling a little bit ill, but he will be back on the next Chris and Mark webinar. And with that in mind, I'll take any questions. You might have to unmute yourselves.
Chris, could you talk a little bit? You mentioned compatibility, and so we got a grower that has iron chlorosis. on soybeans, and he's looking at adding some NanoK to it. Can you discuss that a little bit?
Yeah, so pulse crops and soy are notoriously challenging to get adequate levels of iron into, and it turns out that there's a positive proportional relationship to the ability of these plants, their root systems, to import iron from the available soil pool when potassium and calcium are present and in present levels, sufficient levels. So I think maintenance of adequate levels of available soil K, and a local extension agent can probably tell them what those levels are going to be a really important aspect of helping that soy grower to get adequate iron in through the root system. In the absence of that, foliar potassium, that's why on soy, foliar potassium has just gotten increasingly popular for that exact reason.
Good, thank you.
It's bringing back days of my being a professor. Someone's got a question out there. All good. Okay. Well, I wanted to thank everyone for our NanoK talk today. This was a presentation that myself and Mark, Jim and Jenny all helped develop. Really important product in our product profile, specifically, to the guys in the Corn Belt. This is a nutrient that's getting increasingly, more attention year by year. The soy guys in the Midwest and Northern Plains, and obviously the specialty crop producers out west. Yeah, please feel free to reach out if you have any questions about the product itself, any mixes that your customers or you're looking to develop. Don't hesitate to reach out. And just wanted to give a little plug for our next in the webinar series. Next week it should be Joe and Mike. Jenny, remind me if I'm wrong here. Talking about corn and bean production for the upcoming 2022 season. Okay, so with that in mind, thank you everyone, and we will make this recording available to anyone who wants it. Just reach out to Jenny when you get a chance. Okay, take it easy, everyone.